Okay, double in pointer. So many of you would have called this a two-dimensional array. It's a good name for it. Um, but now you're in computer systems, right? And um, you would have realized that there's no such thing as two-dimensional arrays. There is no dimensionality in memory, right? It's just one contiguous piece of of, of memory. So what you would have encountered before that you called a 2D array. So let's say this is the first row, this is the second row, and that's the third row. Okay? So you construct this picture in your mind, but in hardware, what this really looks like, it's uh, that's the first row, and after it, in contiguous memory, will come the next row, and then the next row, and so on. Right? So what so how you could think about this double in pointer is that this is a pointer to an end pointer. So that means this is a pointer to an array of ints, a pointer to an array of int pointers, and each of those pointers points to a different row. Okay. So, uh, so I think initializing an array in code would make this process a little bit more clear. So let's see what this would look like. Okay, so first we'll allocate the array of pointers. So array equals malloc. Y dimension times size of int pointer. Okay, so this will malloc y int pointers. So here we have, so let's say this is array. And now we would have just allocated this array of int pointers. Okay, so this is y long. Yeah. Okay, so now we need to initialize the values for each of these pointers. Okay, so for int y equals 0, y less than y dimension, and then y plus plus. Okay. So for the current row, we will array y equals malloc x dimension times size of int. Okay. So here we would have made this. So this will now point to a different row. So each of these pointers will point to a different row. Okay? And this is x wide. All right. So now for the inner array, we will have to so for int x equals 0, x less than x dimension, x plus plus. So now we'll set the values for each of these. So int, or just array y x equals 0. Okay. So hopefully this diagram makes this mental image a little bit more clear. Okay, so I've just redrawn the image from previous and gave it some concrete values. So here we see that array, the pointer array, has the value 1000. So it points to this array of int pointers. I'm using 8 bytes for each pointer. That's why this grows by 8. and then each of these in pointers will point to an integer array. Okay, and you'll see that these grow by 4s. Okay, so what is array 0, 0? So we are trying to read the value from here. Right? So what do we need to read this this value? We need to read this pointer as well as this pointer. So you could see just that this is just array double star. Okay. And if we were to think about this step by step, so what is the value of array? So this is 1000. Okay. What is star array? So this means this is the value at address 1000. So this will be 2000. Yeah, I'm not going to write the OX. And then this is finally the value at address 2000. So let's say this is a 3, then this will be a 3. Okay, so that's this side. Okay, and now on to the more complicated side. So here we are trying to read the value of A of 2 of 2. So that's this thing right here. So we'll need to follow a few pointers to get to this spot. Okay. So first we will do array plus 2. So what is array plus 2? So array was 1000. And then array plus 2. Well, this is pointer arithmetic. So array plus 2 will be 1000 and it's two 8-byte pointers, so it's 100, 1010. Okay, so this gets you this address, and now we need the value there. So we put a star here with the brackets. So this whole thing is 4000, or it's the value right here. Right. Okay. So now, how do we get from 4000 to A of 2 of 2, which is 4008? Well, we add another 2. So add 2, and then this whole thing will be 4008. Okay. Okay. So now we are trying to store into this location. So there's the asterisk, and we put the parentheses around this, and then equals. We'll bring this array over here. Please come over here. There we go. Okay, so that's the full thing. So another approach to solving this would be to handle to think about each bracket as a one-dimensional array. Let me show you what I mean. So we could just think about array 2. So what is array 2? Right. So we're not thinking about the second one yet. So we're just taking the first one. So array 2. Hopefully this part should be easy. So this is just array plus 2, and then dereference that, right? So let's make this equal to x, just to make things a bit cleaner in the next step. So now array 2 of 2. This is pretty much just doing x of 2, right? So this becomes x plus 2. and we're trying to store into this location, so there's the dereference, right? And then we just substitute in for x. So it's star x, which is this thing. And then, so that's x, and then plus 2. Okay. So I think the substitution method, it might save you a bit of trouble, because as you see in the next question, in the next questions, it gets a lot messier, right? Okay. So to recap, yeah, I like to think about concrete values, so that's why we have the values here. Or you can just solve this like a one-dimensional array access, but you do it twice. Okay, so this looks pretty confusing already, right? I mean, do people even write code like this? This looks unnecessarily confusing. And in the pointer arithmetic version, it looks even more confusing. So to approach this type of problem, a good idea is to break this into a series of one-dimensional array accesses, assign that to a variable, and then substitute back in. Okay, let me show you what I mean. Okay. So we'll just start with array 1, 4. Okay, so we'll just do array 1 first. So this as a single array access, this is just star array plus 1. Right, so this part should be simple. And we'll make this equal to x. So then array 1, 4, this could be interpreted as just x at 4, where x is a pointer. So then this again is super simple, just x plus 1. Dereferenced. So then we can just substitute back in for x. So it's something, so it's x plus 1. And we'll just put substitute x in here. All right. We'll make this equal to y. So in the next step, we'll do the full right-hand side. So we'll just start with array 2. And this is just the same thing again, is just a single array access. So this is array plus 2. Oh, I did array plus 4 up here, didn't I? Or, yeah, okay. Array plus 2. And we'll make this equal to z. So then array 2 of array 1, 4, this is just, you could just think of this as z at y. So again, this is a single array access, right? Very simple. So this is just z plus y. And then now we just substitute back in for z and y. So it's star and then z. How much room do I have? Plus y. Plus y. Okay. So here is z. Here's z. And here is y. Here is y. So there you go. That's the right hand side. So that's the hard part, but we broke this up into one step at a time, and each step is super simple. Just don't get confused when you copy and paste it back in, I guess. Okay. So now on the left hand side, so this part should be easy in comparison now, right? So it was what was it? Array 1 5. So we'll just start with array 1. So this becomes array plus 1 dereferenced. We'll call this p. So then array, to store into array 1 5, this would just be p at 5, right? So this is just star p plus 5. And then we just substitute back in. So it's star p plus 5. We'll put p in here. Okay. Okay. So that's the left hand side. So on the right hand side is just this thing, right? Okay. There you go. So that's how you get this step by step. I hope I did this right. Yeah. Anyway, so honestly, this takes just a lot of practice, actually, if you want to do this fluently on exams. Yeah. I think substitution works decently well the other way around as well. So here we see that we should be able to recognize that this is just like a single array access, right? We can call this x or array array 1. Okay. So we can call this x. So this whole thing, it becomes just star and then x plus 2. Okay. And if we look at this as a single array access, this is just x add 2. Right. And then we put this all together, we substitute for x here. So this becomes array 1 2. Right. All right. Last question. So keep in mind the order of operations here. If you're ever unclear, you should look up the order of operators in C, and you'll see that the dereference operator precedes addition. Okay, so this, you dereference array twice, and then you add 1. So this is just some number. Okay, so hopefully star array, you follow the pointer twice, so this is just array 0 0. Right? If this was a more complicated expression, of course, like previous questions, you would just break this down into a series of one-dimensional array axes. Okay, so let's call this whole thing, so this is just plus 1, let's call this whole thing x. Okay, so this whole thing will be called x. So let's rewrite this. So it would be star array plus x. So now we can also think of this the star array. This could be just plus 0, right? So what does this look like on the inside now? Now on the inside, this looks again like a single array access, right? So here we have something that looks like array at x. Okay, and we'll call the do I have to substitute? No. Okay. So let's so let's call this y. And we'll just rewrite this. So then it's star y plus 0. So now this looks like a single array access again. So this whole thing, this is just y at 0. Right? And now we substitute back in for everything. So we just have y of 0, which becomes so what's y? So y is array x. So then we have array x at 0. Now what is x? So we substitute in for x from here. And then this whole thing is this whole thing becomes array 0, 0, plus 1 at 0. Okay. Right? Yeah, and then equals 13. There we go. So again, we just break this down into a series of one-dimensional array accesses and substitute back in. Did I write this right? Okay. Yeah, just practice.